This video is to introduce to IB math teachers, math applications and interpretations teachers, a manipulative to use to introduce Voronoi diagrams. And this is a little program that I wrote to help you do this, especially in an online environment. I was thinking about doing something like this on paper, but when you're online, it's a lot easier to have something that's on their screen. So basically, first have the students go to this link here. I'll put it in the description of the video also. And then have each student open this up. And this is made on Scratch, which is a graphical programming environment that is good for students, but it's also really good for making math manipulatives. So basically, each one of these little houses that looks like domino side is a pizza restaurant, and to start the manipulative you just press the green flag, and it will rearrange the pizza restaurants until it makes a map in which the pizza restaurants are pretty far away from each other. If it ends up making a pizza restaurant distribution where two restaurants are too close to each other, it'll immediately try to make a new one until it finally arrives on a map which is fairly well spaced apart, like this one. So each student will end up with a completely different map than you or from each other. Then ask the student to think about if you have a neighborhood with 4 pizza restaurants, color-coded pizza restaurants like this, that, obviously, if you click your mouse close to a pizza restaurant, you will identify houses that will be served by the nearby pizza restaurant, right? So you can see that the red pizza restaurant serves the red houses, and the green pizza restaurant serves the greenhouses. So they can click around the pizza restaurant, and they can easily see that the houses around that pizza restaurant are going to be served by that restaurant. Now, then the next step is ask the student to identify houses which are exactly in between 2 pizza restaurants, and in which case they would be basically on the border of at least 2 pizza restaurants. And if they do that in a correct manner, then you can see that instead of getting a red or a yellow house, they end up with a purple house. So basically what the purple house means is they are correctly identifying houses that are on the border between the yellow pizza restaurant delivery area and the red pizza restaurant delivery area. Okay? And then if they get a little too far off to the left or right, you can see then that it ends up identifying the house as being covered either by the yellow or the red delivery area. Okay? So the same thing, you can do that between red and green, for example. The student probably is going to be easily identify the house that's exactly in between the red and the green, halfway in between, and then they'll start moving to the left and right on either side, and then they will begin to see that the borders between pizza delivery areas are straight lines, right? And as they extend their straight lines, they will start to see that eventually these straight lines, when they intersect with each other, end up forming vertices, like that. So between the yellow and the red, for example, they might put their cursor kind of right in between and see that that is one of the purple houses. And they might start to see the concept of the angle of the border, that the border has a right angle relationship with the lines that connect the pizza delivery restaurants. So at this point, they probably have drawn most of the borders here and maybe even found some of the vertices in the Voronoi diagram. And then now you can show your screen where you've done the same thing, and then you could have a discussion about the relationship between the angle of these lines and the imaginary lines connecting the pizza restaurants, right? That, you know, somebody might say, oh yeah, so it looks like a line which connects the yellow and green pizza restaurant would be perpendicular to the purple border. And then to facilitate the teacher or the student making visual diagrams of this relationship, there is also a function where if you put the cursor on the green pizza restaurant and you want to draw a line from the green pizza restaurant to the yellow pizza restaurant to show that this line between the two is perpendicular to the purple line, you can put the cursor on the green restaurant and then you press spacebar, and then you put the cursor on the yellow restaurant and hit the spacebar again. It'll draw a line connecting the two, and then you can kind of see that, oh yeah, it is perpendicular, right? And then you could even go one step further and say not only is it perpendicular, but the purple line is actually exactly in the middle of this line connecting the green and the yellow pizza restaurant. So, you know, using this manipulative, the students can take their intuitive ideas about where the pizza delivery area borders would be and extend that, and, you know, with the feedback of the house turning the right color when they're drawing the border correctly, they can start, you know, figuring out, oh, it's a straight line, the straight lines intersected vertices. Eventually they can also make the conclusion that these purple borders are perpendicular bisectors of the lines which connect each of the pizza restaurant pairs. So, and then you can use the spacebar line drawing function to help them see that. Okay, so this is part of what I use for to introduce concepts. I usually make what I call an investigation. Sometimes they're really good for the toolkit concepts that are used in the IB curriculum. Sometimes they're just really simple manipulatives like this, but it's kind of like taking the students' knowledge about, you know, physical things in their daily life and connecting it to the math concept to introduce it to, so that there's like a something that will anchor them to the concept, so later when you're talking about the concept you can always refer back to this concrete example, something that is you know, pizza delivery, it's part of their life. They can easily think about a pizza delivery map and how that is related to a Voronoi diagram. You can also extend this. I mean, once they get to the point where you talk about these vertices, you can talk about how, you know, Voronoi diagrams can be used to figure out, you know, what a coverage zone looks like for, you know, a pizza delivery restaurant, or a cell phone coverage tower, etc. But you can also take it the other way and say, okay, what happens when you want to find points on the map which are as far as possible from, many different nodes, and, that would be the toxic waste dump problem. So the toxic waste dumps would be located ideally at vertices on the Voronoi diagram, for example. Okay? All right, that's it.